So hello everyone, my name is Sachin Sharma. So we are going to see the zero matrix, set matrix zero problem. So what is in this problem? There is a array. This problem is mixed with the array and matrix, array plus matrix problem. So this is the uh, what matrix by m into n. M is a row, n is a column, and this is the another matrix 3 by 4. This is the row and this is column. So we are going to solve this problem. What is in this problem? So given the matrix, if the element is of a matrix 0, if any element of a matrix 0, then it's a entire column and entire row will become a 0, like this. If this element is 0, so this row and this column become 0. So output should be like this: 1 0 1 0 0 0 1 0 1. So this becomes 0 and this becomes 0, like this for this input. And this is 0 and this is 0. So the first column become a 0 and first row become a 0, and remaining this also become a 0. Remaining element should be like this. So this is the output and this is the input. So what are the approaches of this? There is the three approaches. First approach is a brute force, and second one is a taking extra uh, 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 taking extra space, of um, two vectors, row and columns, and this approach is called minus one approach. And third approach is a optimal approach, and it is not taking two extra vectors for a row and column. So space is order of 1. So one the first approach is, if we see the we will go one by one to the all elements. So uh, row is a m and column is a n, number of elements. So if we see the 0 in any row and column, then all the row all the row and all the column become a minus 1 except 0. So it is a non-zero, so it become a minus 1 and it become a minus 1. Okay, so let's change the pen. So it become a minus 1 and it become minus 1, and because of this minus 1 minus 1, so minus 1. Then we will go to this, we will skip this minus 1 minus 1. We see the 0, so this row already become minus 1, so we will cross this column, last column, minus 1. Okay, so this becomes, so now the again we this all row is completed, first row is completed, then we will jump to the second row. The second row is a minus 1, skip 4, skip 5, skip minus 1, skip minus 1, 3 1 5 minus 1. So the uh, output will become like this: minus 1 uh, minus 1 0 minus 1 4 2 minus 1 minus 1 3 1 minus 1. Now what we have to do? So it will happen in a uh, n plus m for each element, and we are roaming with for each element and for each element we are checking, and for one element this can be the worst case. We will check the whole column and whole row. So up to now the time complexity is this. So the second step in this, if we see the -1, then make -1 to the 0. So the 0 0 0 0 0 4 5 0 0 3 1 0. So it will happen in a n into m time. So the total time complexity of a brute force is a n plus m, n into m plus n into m. So the time complexity will become n plus m n star m. Okay, so this is not a array. It is equal to the number of rows. So we say this is a row size and this is the column size. So m into n. So size of this is m and size of this is n. So what is this approach? So if we see the we will go one by one to the all element. If we see the 0, then columns are rows are 3, columns are 4. So for this 0 1 2 0 1 2 3, for first element in a row vector, we will see the is any in the first row any element is 0. Yes, the first element is 0 and second third fourth is 0. So we will put the first column is 0 and second column is not 0, and third column is not 0, or this is 0. So this is not 0, so put 1. Okay, so any of this is 0, then put 0 here. Okay, and then comes to this second row. If this is 0, no, this no, so put 1. Is there in a third uh, row is any element is 0? No, put 1. Now the up to the time complexity is this, because we are uh, moving from checking every element, so time complexity up to this is n into m. Now what we are going to do, so this is our matrix. So check 0 row is the first, and this is a 0, so put 0. Okay, and first second row is not 0, third row is not 0, first column is 0, so put 0. Second column is not 0, third column is not 0, fourth column is 0, so put 0. So how much time it will take? So to check, it is also taking it can, in worst case, it is also taking the n into m time. So the total time complexity is n into m 2 times. Okay, so the of n into m time complexity for this approach. and space complexity is order of max n plus m. Okay, because we are taking this extra space now, that's why. Second approach, let's see the third approach. Okay, so I already write down the steps. So what are the steps? So let's understand the steps. They are the six steps, very small steps are there. So if, let's see, this is the matrix with index. I am assuming the index is start from the 1 to n. Okay, 1 to n and m. So first check, first rule is saying check 1 to first row, second column to first row, last column. Is there any element is 0? Check. If any element is 0, then uh, put c equals to 0. C0 is a variable. Okay, and we put 0. If 1 to from 1 to 1 4 is there, no element is 0, then we will not put anything in C0. Okay, now we will put 1 in C0, or whatever the element in this, whatever the element in 1 1, then we will put if 0 is not there. So second thing, now check uh, from 2 to second row and second column to second row, last column, is there any element is 0? If yes, let's say the 2 3 is 0, then we will put first 2 3 means third column, and second row 0. S- uh, 2 3 is 0 means the second row, it is a second row and third column. So we will make second row first element 0 and third row column first element 0. So let's see, this is 0, then we will mark as 0 and we will mark as 0. Okay, we will repeat these things, we will repeat, and this thing for all remaining elements from this portion. First for this, let's see, this is 0, then we will mark this and this 0. Okay, and fourth rule is this: if from second to end column, second means here to here, if any element is 0, let's say this and this is 0, then make whole column is 0, this and this. And for second to end row, from this of a first column, this, if anything, any element is 0, then make whole row is 0. Okay, and last roughest. So c0 if c0 is a 0, if c0 is 0 means we will make uh, we will make a first column as 0. Okay, first column as 0, first column as a 0. And 7 point is, if 0 0 0 0 element means first element of a matrix is 0, then we will make first row and first column as a 0. Okay, then we will make this and this 0. These are the 7 rules. Now apply these 7 rules here. So it is saying from here, first rule saying, is there any 0? So put 0, otherwise put whatever the element in this. Okay, now check, is there any element from there from 4 5 2 is 0? No. From any element from 3 1 5 is 0? No. Okay, now we will go we will go thus from second column to n. Is there any element is 0? If 0, then make whole column as a 0, then this is 0, and make it 0 0. Okay, make it 0 0. Now check from second row to last row of a first column is any element is 0. 3 not 0, 4 1 not 0. So but we will not replace these elements, okay, with 0. Now sixth rule says if C0 is 0, then make first column as a 0. Yes, in our case C0 is 0, so make first column as a 0. Okay. Now seventh rule, if M0 first element is 0, then make first row and first column as a 0. So yes, 0 is here, so make first column and first row as a 0. So answer whatever the answer left will be our answer. 0 0 0 0 0 0 4 5 3 1 0 0. This is the our answer. So from step 1 to this this we are covering, so it will take order of m into n, and from fourth step and fifth step it also taking the order of n into m. So and six step and seven step will take order of 1, and order of 1. But if c0 is 0, then we have to make a whole column is 0, so it will take order of n, and this is step take order of m plus n. So total time complexity is order of m into n, with 2 times of m into n, so we will say roughly m into n. Okay, this is the time complexity. Good approach. So we will go with the second approach. So let's see the second approach. Okay, this is the better approach. So in this approach we have to take extra array,